Okay, we are going to do the same idea. We're going to double the height and double the radius of a cone, but this time we're going to investigate what happens to the volume. So the height of a cone is doubled. Does this double the volume? Okay, so volume equals 1/3 pi r squared h. Okay, so let's just draw our cone. Okay, we'll put radius equals 1 and height equals 1. And then cone 2 is going to be the same as last time. Radius equals 1, and then height this time equals 2, because we're going to double the height. Okay? So let's make the first one blue. Blue. Volume of number 1. 1/3 of pi r is 1 squared, and then h is 1. So we get basically 3.14 divided by 3. So let's put 1.046 continuous. Okay, and that's the volume. So we'll just put units squared, cubed. Okay, and let's do the height of the second one. Let's use purple. Okay, so the volume of the second one, 1/3 pi. The radius is still 1 squared, and then this time the height is 2. Okay, 1/3 pi r squared 2. So we're basically doing 2 times 3.14 divided by 3. I get 2.09. 3 continuous units cubed. So if we take 2.093 divided by 1.046, what do we get? 2.093 divided by 1.046. I get 2. So it might double. I'm going to check one more time, because sometimes using smaller numbers such as 1 and 2, or sorry, ones and twos, it doesn't justify, because ones sometimes work out nicer than other ones, like other numbers. So let's double the 2. Let's try the height of 4. Okay, so let's go, and we'll call this volume of 3. 1/3 pi r squared times the height, which is 4. Okay, so 1 divided by 3 times 3.14 times 4. I get 4.186 continuous. So let's divide 4.186 divided by the previous one, 2.093. And yes, it does double. Awesome. So if you double the height of a cone, it does indeed double the volume. Okay, and now let's talk about the radius of a cone. So let's do the exact same thing. Let's explore volume, and let's talk about the radius. Okay, radius. Let's use the bigger numbers this time, because this time the radius is squared. So we sometimes have to be careful, because when you square 1 and then when you square 2, it works out nicer. So we'll do radius is 1 and then height's 1. And radius is 2 and height's 2. Or sorry, height's 1 still. We'll try this, and then if this works out, we'll try also the radius being 4, which is double 2. Okay, so volume equals 1/3 pi r squared h. Okay, again, 1/3 pi. 1 divided by 3 times 3.14. I get 1.046. Okay, and then for the second one, volume equals 1/3 pi r squared, which is 2 squared, h. 1 divided by 3 times 3.14 times 2 times 2. This time, 4.186. Okay, so if we take, and that's units cubed, if we take the 4.186 and we divide it by 1.046, it's about 4, right? Because if you think about it, we went from like this 1, and now the same thing, 4. So this actually made it 4 times as big. So the radius of a cone is doubled. Does this double the volume? Therefore, no, it does not. And then the first one, therefore, yes, it does. Yes, it doubles the volume. Okay, and that's it. So just keep this in mind when you are getting asked questions. If something doubles the height or doubles the radius of a cone, keep in mind that we don't just double the surface area or double the volume. You can only double the volume when the height is doubled, and that's it.